Assalamualaikum students, myself Irfan and you are watching Irfan Sir's Academy. Today we will discuss about explicit differentiation. What's an explicit differentiation? Explicit differentiation, if you want to know what is explicit differentiation, first of all we should know about what are explicit functions. Explicit functions are those functions in which there is a dependent variable. Suppose there is a dependent variable, that's y, and it is a function of an independent variable. Suppose it's a function of an independent variable, that is x, and these dependent and independent variables, these are separated with each other. These are separated from one another. Like we have a function y equal to 2x plus 3. This is a function, and here dependent variable it is y, and independent variable that is x, and we want to find here the gradient or slope of this y upon x. With respect to x, what is the gradient of that function? Suppose this what is this function? You know that this is the equation of straight line y is equal to mx plus 3, and you are able to find what will be the graph of this function. If you know that this will be y equal to slope, it will be 2, and intercept it will be 3. I know this is an y-intercept, and what will be that? And slope is positive, it will be increasing. The graph will be like that, and there is a slope. This intercept, it is 3, and the slope of this function, that is 2, and which is increasing also. Now we have to find what is the derivative of this function, or in another way you can find the gradient of that function. Now this is an explicit function. In order to find its derivative, we will differentiate simply this function. Suppose with a function that's y is equal to 2x plus 3, we will differentiate the function with respect to an independent variable, with respect that's x here, because we have to find what's the instantaneous change in y with respect to x, or we have to find what's the gradient, which means it gives the instantaneous change in one quantity, that's dependent quantity, with respect to an independent quantity, that's here x, and dependent quantity is here y. It will be dy upon dx, and it will be another 2, it will be a constant and will come out, and there will be derivative upon dx plus d upon dx of 3. It will be dy upon dx, it will be equal to what will be derivative of this function x with respect to x. It's 100% instantaneous change, it means it will be 1, plus what will be derivative of this 3 with respect to x? What will be the change in 3 with respect to x? No change. 0. No change. It will be 2 into 1 that will be 2 plus 1, 0, that will be equal to 2. This is the slope of the function. If you find this, the slope of the function, that's also 2. This is you find by geometrical method, and this is you find using the calculus method. The slope of the function. Slope of the function you find here, or the gradient of the function you find here, that will be equal to dy upon dx. It will be slope of the curve, slope of the tangent to the curve. If it is a curve is nothing, curve may be straight line, it may be a straight line also, curve is a locus of points. Now here it's a straight path, and you have to find what is the slope. You have to draw tangent. If you see there, if you draw here tangent, the tangent is the same line. If you find what is the slope, you have to differentiate that function. After differentiating, we get the slope equal to 2. And here also, what will be the slope? That will be equal to 2. Is it easy? This is explicit differentiation. Another example, we will take a very simple example. I will take some complex examples. Suppose we have a function y equal to f of x, the function of x, and here f function of x, it means here y and x, these are separated from each other. Y is a dependent variable, purely dependent on x. Suppose y is a function of, it is x square into sine of 2x, x square into sine of 2x, and we are here to find what will be the slope of this function, and you have to find the gradient of that function. What is that? We will simply differentiate this function. After differentiating, what will be the answer? It will be d by dx of y, it will be equal to d by dx of x square into sine of 2x. Now see here, both the functions, these are functions of x. This x square function of x, sine of 2x function of x. It means these are the two functions which are in product. We have to find the derivative of these two functions which are in product with respect to independent variable, that's here x. And we know that what's the derivative of the product of two functions. You know that it's u derivative of v upon x plus v derivative of u upon x. You have to differentiate first one function and keeping one as if, and then plus you have to take another function as if and derivative of the one function that you didn't differentiate before. Isn't this clear? It's u differentiation of v plus v differentiation of u. You take plus sign here. Now what will be that? It will be x square derivative of sine of 2x plus it will be sine of 2x into derivative of x square. Isn't this? Okay, nice. What will this? It will be x square. Here what we use? Here we will use the chain rule. You can simply use the chain rule. Because in case of explicit differentiation, we use simply the chain rule. What is chain rule? Very simple. I will give you a simple idea. If you follow this simple idea, you will not find any type of problem that you cannot handle. There are a lots of problems. There's a lot of numerical portions in case of IIT-JEE examination or in any other competitive examination. You will find in all over the world. If you find any type of explicit differentiation and you find where you have to use the chain rule, use this rule. Very simple. What we have to do first, according to chain rule, first you have to differentiate the inner function. Is now you have to find here the derivative of sine of 2x with respect to x. If it could be sine of x, derivative of sine of x with respect to x, you know that is cos of x. But it's not sine of x, it's sine of something other. It's sine of 2x. What will be derivative? It will be, you have to first differentiate the outer function. Sorry, it's the inner function. You have to differentiate first the inner function and then you have to differentiate the outer function. O means here outer, I means here inner function. Or you can simply use what is the derivative of 2x d by dx of 2x into derivative of the inner function, that is sine of 2x. That you write here, d by dx of, here you write what is different, sorry, forget here. Inner function is 2x. What's derivative of 2x? It is 2 int. What is derivative of sine of 2x? It will be cos of 2x. Or simply you can assume that, suppose for a second, it's not 2x, it's x. What's derivative of sine of 2x? Sine of x, it's cos of x, We assume that 2x is x. Now, the number or the function or the quantity you assume as x, you have to differentiate that. You have to multiply that differentiation of that function here. What is the function you assume as x? That's 2x. Derivative or the differentiation of 2x, that's 2. You multiply that 2. Or simply first differentiate inner function and then give the derivative of the outer function. Okay, nice. What's its sine of 2x? But derivative of x square, what you do? Put down the power, it will be 2, and what will be derivative of this? It will be x. It is 2, put down the power and subtract the power by 1, it will be 2x. And here it will be 2x square cos of 2x plus 2x sine of 2x. I hope you understand this. I hope you understand what's the chain rule here. And here, if you find that 2x is in common, and it will be x cos of 2x plus sine of 2x. The final answer. Very nice. Okay. Now we'll see what will be the derivative of different functions. This was a very simple example. Go towards the complex example. Suppose we have function y equal to sine inverse of 2x upon upon ln of x. Or suppose we have ln of 2x. I write here ln of 2x instead of ln of x, so that we can do such type of problems which will be more complex. Now what we will do, we will differentiate this. It will be dy upon dx, derivative of y with respect to x. What is the derivative? What is the this sine inverse is a function of x, ln is a function of x. It means whole function, this function y is a quotient of two functions, and you know that what will be the derivative of the quotient of two functions? D by dx of u upon v. It's v derivative of u minus it is u derivative of v upon denominator square, that's v square. Isn't this? Okay, nice. Now what will be this? It will be v, that's ln of 2x. Derivative of sine inverse x. I hope you know what is derivative of sine inverse x. It's 1 upon under root of 1 minus x square. But it's not pure x. It's not x. It's 2x. What we have to do, first of all, write the derivative of sine inverse of, assume that 2x is an x. Derivative of sine inverse of 2x, it will be 1 divided by under root of 1 minus the angle square, that's 2x square. And multiply the derivative of the inner function. What's 2x? 2x derivative, that's 2. Isn't this? Now, then we have to write the negative. It will be u. What will be u? Sine inverse of 2x. Sine inverse of 2x. Multiply. What will be derivative of v? V is here ln of 2x. Derivative of ln of 2x is 1 upon 2x. Isn't this? Derivative of ln of x is 1 upon x. Derivative of, assume that this 2x is an x. Derivative of ln of 2x, it will be 1 upon 2x. Multiply the derivative of this 2x, that will be 2. What will be this? I forgot that. What's denominator? That's ln of 2x whole square. And it will be 2 ln of 2x upon under root 1 minus 4x square, and it will 2 with 2 will cancel out, and this ln of 2x upon whole square, it's in the quotient of both the functions. And what will be that? This will be sine inverse 2x upon x upon ln of 2x whole square. I hope you understand this. Very easy. You are able to find the derivative of such complex functions by using some chain rule here in explicit differentiation or in explicit functions. Another example we will take here is that example. Suppose we have a function y. I hope you understand here y and x, these are separate from each other. You are given only one value of y here. You are given only one value of y. They get separated from each other. In the implicit type of functions, you will not find simple things like that. There, y and x are not separate from each other. There could be two values of the dependent variable. We will see later on. Y is equal to, we will take a function. Suppose it is tan of tan square 2x. And the product will take e power 2x. E power 2x. But with derivative, it will be dy upon dx. It will be equal to, what will be, it's product of two functions, and we will take tan square 2x there, tan square 2x there, and we will find the derivative of 2x. Then what we find? Take another function. We take another function plus, that's e power 2x multiplied by derivative of, it is tan square. Can we write tan 2x whole square? Yeah, we can write. Okay, nice. It is tan square 2x. What's derivative of e power x? Derivative of e power x with respect to x, or the gradient of e power x with respect to, that is e power x. But it's not here e power x, right? Suppose 2x, it's an x. Suppose for a second it's an x. What's the derivative of e power x? E power x. E power x. But it was not an x. You have to multiply the derivative of that. This is the chain rule method. What is derivative of 2x? That will be 2 plus derivative of e power 2x. This remains as if derivative of tan square 2x. Suppose first of all we will deal like, suppose this function we know the derivative, the derivative of x power n. It's put on the power and you have to subtract 1 from the power. That's nx n minus 1. What we will do here? We will do, suppose this is an x. Suppose, we don't know. Suppose this is an x. I don't know what is this. Suppose it, because this is a function of x. If this will be another variable, we cannot suppose this is an x. Suppose this is an x for a second. What will be differentiation or derivative of x power n? It will be put on the power. You have to subtract 1 from the power. Then 2x, 2 minus 1 is 1. But the quantity you suppose it to be x, the quantity you suppose here to be x, you have to multiply the derivative of that quantity. But you have to multiply derivative of tan 2x. Okay, nice. Now what will be this? This will be e power 2x and 2, it will be in common, see, and here it will be tan square 2x, left here with tan of 2x. Now we know the derivative of tan of x. The derivative of tan of x, it is 6 square x, but we don't know about the derivative of 2x. We suppose this is an x, 2x is an x. What is the derivative of tan x? 6 square 2x. The quantity we assume it to be x, we have to multiply that differentiation or the derivative of that function. 2x, that's 2. Is it this? Okay, nice. Now what will be in common also? Tan of 2x. 2e power 2x into tan of 2x. That will be tan of 2x plus it will be 2 sec square 2x. This is the derivative of this function. Y equal to tan square 2x into e to the power 2x. Is this easy? Okay, nice. This is what is the explicit differentiation. But in case of implicit differentiation, you will not find such a simple method, or you will not be able to use, you will use their chain rule, but their x and y, the dependent and independent variables, those variables will not be separated from each other. There will be 2 values of the dependent variable. It could be 2, it could be 3 variables. What will be this? We will see.